The oldest stars in the universe aren't all scattered around randomly. They're located in these structures known as globular clusters. It's in these structures where the oldest stars in the universe reside. A globular cluster is a stable, extremely tightly gravitationally bound group of tens of thousands to millions of stars, and they're pretty much associated with all types of galaxies. And within our home galaxy, the Milky Way, they're found within the halo and the bulge. Today we think that the universe is about 13.8 billion years old, give or take a few years, and astronomers have actually found stars in globular clusters that are almost as old as the universe. In fact, stars in globular clusters are so old that they were used to help independently verify the age of the universe. Researchers can determine the age of a cluster by its metallicity, the relative amounts of elements like oxygen, iron, and any other elements heavier than helium, which astronomers collectively just decided to call metals. Globular clusters near the center of the Milky Way are older than the ones further out, and the ones near the center have similar ages to each other. This indicates that the younger clusters may have been formed during a merger with other galaxies, and the older clusters may be relics from when the Milky Way was born. It's the intense gravitational attraction between globular clusters that give them this spherical shape. This is in contrast to a lot of galaxies actually, because you'll see a lot of irregular galaxies and they don't have that much of a structure, mainly because they're less tightly gravitationally bound. But globular clusters are so tightly packed that they just form a spherical shape. You'll mostly see redder, older stars in globular clusters because of their ages. However, more recent research shows that clusters often have several generations of stars, showing them to be more complex than previously thought. Understanding why this is the case is still an area of active research, which makes sense because that's a tricky question to try and answer. It's not only the stars within globular clusters that are long-lived, but the actual structure of globular clusters themselves. Globular clusters are of great use to astronomers, like pretty much all astronomical objects are, but these are helpful not just because they can help constrain the age of the universe, but also because almost all the stars formed at approximately the same time, location, and with a similar initial composition. So investigating globular clusters offers unique information about how the stars form and evolve. However, it's quite challenging to resolve individual stars within a cluster just due to how densely packed they are. Studying populations of galaxy clusters can also help with understanding galaxy formation and evolution. Globular clusters are scattered around galaxies, but they aren't all of the same age and they move in very different orbits around the galactic center. So astronomers could track the motion of globular clusters in other galaxies to find signs of past collisions, which helps trace the history of galaxy evolution. The number of globular clusters within a galaxy seems to depend on its mass. So for example, in our largest galactic neighbor, Andromeda, it has about 400 globular clusters. The giant elliptical galaxy M87 has over 10,000 globular clusters, and in our home galaxy, the Milky Way, we have about 150, but there are probably more than that. As already mentioned, stars in globular clusters are densely packed. This leads to the creation of binary systems, including those with so-called compact objects. These compact objects being white dwarfs, neutron stars, and black holes. Some studies show that such exotic binary pairs, such as white dwarf neutron star pairings, happen about 100 times more often in globular clusters than in the rest of the galaxy, which does make sense. And many of these systems are potential sources of gravitational waves, so LIGO scientists would be looking at these systems with great interest. So, on the face of it, a group of old, red, mostly dormant stars in a group can seem quite boring, but when you take a deeper look into it, it's actually more interesting than you might think. If you're interested in reading more about globular clusters, I have references to things I mentioned in the description below. I also have my Twitter, TikTok, and website in the description, so feel free to check those out, ask me any questions, and I guess I'll see you next week for another episode of me talking about astrophysics.